Good day everyone. We are from Group 1 Section 1. We have 5 group members: Aiman, Dhiren, Mi Kwachingwan, and Jasper and Dirusha. What is displacement current? Displacement current definition is defined in terms of the rate of change of the electric displacement field. The unit of displacement currents are same as that of electric current density. Displacement current is not an electric current caused due to moving of charge, but is caused by a time-varying electric field. So as you can see, this is the difference of the formula of static field and the time-varying field.
Hi, I'll talk about the formulas that are related to Maxwell equations. Okay, how can we obtain the formulas that are related to Maxwell equations? Is starting from the continuity current equations, which is divergence of J is equal to negative differential of rho V. Rho V is the charge gathered around on the conductor, and for the J is the space between both of the conductor, where is an open circuit, where the current couldn't jump between this medium. Okay, and we do know that J is equal to a curl of H, and so we can see divergence of curl of H is equal to negative differential of rho V. And from previous chapters, we do know that rho V is also equal to divergence of D. So from this equation, we can see that divergence of curl H is equal to differential of divergence D. And according to vector identity, divergence of curl anything will become zero. So for these equations, this formula is not valid because on the left hand side is equals to 0, but on the right hand side there is a value because D is a time varying field where it always have value inside it. So here comes the Maxwell equations. So Maxwell modified the equation by adding on the positive differential of divergence of D. So we can see this divergence of curl H is equal to differential of divergence D and negative of differential of divergence of D. And from this equation, we can simply modify it. It becomes this equation. Divergence of curl H equals to divergence of dd over dt plus divergence of J. And how can we obtain this divergence of J is because of the first equation we obtained from the continuity current is which is divergence of J equals to negative differential rho V, where rho V can become divergence of D. So here's the equation. And from this equation, we can simply neglect the divergence and become this equation. So curl of H is equal to J plus dt over dt. From this J is actually the conduction current density, where it's also known as Jc. Jc usually we open it to find the loss of energy. dd over dt is the displacement current density, also known as Jd, which is the current flow in the dielectric material of the capacitor. Usually when the bulk of the conductor is perfectly dielectric, Jc can be neglected because Jc is a conduction current density where there is a conduction happen inside it. But for perfect dielectric, there is not conduction current between side. So we just neglect this J and form this curl of H is equal to Jd. Next, we will show you the example of how we can apply these formulas and to involve our understanding of this formula in the example.
Okay.
Design and usage of capacitors. Capacitor is a passive electronic component that stores electrical energy in electric field. It works by distributing charged particles on generally two plates to create a potential difference. Capacitor can take a shorter time than a battery to charge up, and it can release all the energy very quickly. How does it work? When a capacitor starts charging, there is no conduction or charge between the plates. The displacement current in a capacitor is a current that flows through the dielectric material between the plates of the capacitor. This current is caused by changing electric field in the dielectric, which induces a flow of charge across the plates. The displacement current is equal to the rate of change of the electric flux through the dielectric. One example of a real-world application of capacitors and displacement current can be seen in power factor correction circuits. In power systems, voltage and current waveforms frequently do not match, which often lead to power loss and reduced efficiency. Power factor correction circuits use capacitors to correct the mismatch by introducing a displacement current that is in phase with the voltage waveform. The usage of displacement current in power factor correction circuits allows for a more efficient use of power in electrical systems, which leads to a more high energy savings in huge industrial and commercial operations. This technique is used in a wide range of industrial and commercial applications, including factories, office buildings, and data centers.